What are we going to be going over today?
Fraction operations.
How'd you know, man?
Bubble letters.
Yeah, fraction operations. That is what we're doing today. Which means exactly what it means. We're going over all the operations with fractions. Which obviously means adding fractions, subtraction fractions, multiplying fractions, and dividing fractions. I'm going to give you a fair warning right now. The adding and subtracting of fractions are the ones that we're going to take most of our time in, because that's the most challenging one for students. And believe it or not, the multiplying and dividing is the easier of those two. Let's dive right into it. How about that? So we're going to start with adding first, and adding and subtracting are both the same rules. Subtracting just a little different, but essentially the same thing. So let's say we're given a fraction such as 3 over 10 plus 5 over 10. Can somebody please tell me, what does 3 over 10 plus 5 over 10 become? Yes?
8 over 10.
8 over 10. Why, you ask? Well, it's pretty straightforward. All we did was add the numerators across because the denominators are the same. So the key here, my friends, when it comes down to adding and subtracting fractions, they must have the same denominator. All right? If they do have the same denominator, your answer will have that same denominator, but the numerator will be the sum of the numerators. 3 plus 5 is 8. All right. That's it. That's how you add fractions. We're done. I'm going to pass out the worksheet now. Of course not. There's always tricks with math. Am I right? First one being the obvious one. What if, Neil, we are not given the same denominator? What if we are given 5 over 6 plus 1 over 4? By the way, I shouldn't have erased what I just erased. What was the answer from the one before? It was 5 over 10. Don't forget, your final answer must be simplified, right? So 8 over 10 was what we left off with from the one before, 8 over 10. What could that be simplified down to be? Well, if we divide both by 2, just because we love our number 2, we end up getting 4 over 5, and you can't do any more division. 4 over 5 is the reduced fraction of 8 over 10. So don't forget that, my friends. You always have to simplify. Anyways, back to this one. 5 over 6 plus 1 over 4. So, if you notice, these two fractions do not have the same denominator, so I cannot add the numerator straight across because, again, they do not have the same denominator. What we need to do is find the same denominator. We have to create the same denominator. And the way to do that is to find the least common denominator. The least common denominator. That's the word for the number that the denominators have in common in terms of its multiples. I don't know how to word it, but I'm going to show you instead because I'm pretty sure that's what you guys want to see. This is what I mean. I have created something called the Racetrack. Every student loves it every quarter. It's called a racetrack. What we do is we build a racetrack. And we put our denominators there to compete with each other, sort of as if they were cars on a racetrack, right? This is the little track that they're going to be running or speeding through. What we do is we lay out not all the multiples, but a good chunk of multiples of each of those numbers. What I mean by that is 6 times 1 is obviously 6. 6 times 2 is what? 6 times 3? 6 times 4, you could probably stop right there or go a little longer if you didn't spot what comes next. But you lay out a couple of its multiples of both numbers. So 6, those are its multiples. 4, do the same thing. 4 times 2 is what? 4 times 3 is? Man, y'all are just loud. 4 times 3 is 12, and you stop right there. Because if you notice, we found the least common denominator. The matching denominator is 12. You're always looking for the matching one. The reason why we do that is because that is what they are going to be converted into. This 6 and this 4. They are going to be converted into a new fraction. A fraction in which they have a new denominator, in which the answer will come out with a denominator of 12. That's the point of why we do that. We find the least common denominator so that we could pretty much have matching denominators. But the thing is, you cannot put the same numerators in. Because of that rule that I said earlier today, which was, whatever you do to the bottom, you got to do to the top. So ask yourself, this 6 right here, what did you multiply that 6 by to create this 12?
2.
You multiplied it by 2. So guess what? You have to multiply the 5 by 2. What's 5 times 2? This 4, what did you multiply the 4 by? You multiplied it by 3. So whatever you do to the bottom, you got to do to the top. 1 times 3 is? Those are your new numerators. You just found the new numerators. This fraction is pretty much obsolete. We don't need it anymore. This is my new fraction problem. 10 plus 3 is what? Because, before we answer that, because they have the matching denominator from what we did earlier with the racetrack, we can now just add straight across. 10 plus 3 is what?
13.
So the answer is 13 over 12. So you have to always find the least common denominator. Ask yourself, the original denominators, as in the 6 and the 4, what did you multiply them by to find that least common denominator? Then multiply the numerator by that same number to create your new numerators, which you then just add straight across. Question for y'all. 13 over 12, is that my final answer?
No.
What's the final answer?
Well, you gotta break it down to a proper fraction or a proper one. Mixed fraction.
Yep. First things first, always check whether it could be simplified, right? The thing is, 13 over 12 cannot be simplified because
Decimal.
that number 13, there's always going to be numbers, you'll get the hang of it, such as the 3, the 5, the 7, pretty much majority of the first odd numbers. They aren't divisible by anything other than the number itself, except for 9. That is divisible by 3. But 13 is not divisible by any number, so you already know right off the bat 13 over 12 cannot be simplified. But math does not like your final answer to be in improper form, improper fraction. They want it always in mixed number form. So 13 over 12, what we need to do is convert that into a mixed fraction. Do you remember how to convert this into a mixed fraction?
Divide.
Like that?
Yeah, no. 12.
I'm just going to test you guys. Every now and then I'm just going to test y'all. 13 divided by 12. That's how you display it. How many times does 12 fit into 13?
What?
Creating 12 with the remainder of 1. You use your 3 numbers there and you rearrange it into 1 and 1/12. Final answer right there. So, the racetrack. That's going to be the key here, my friends. Finding the least common denominator. That is going to be key 100% of the time. You want to always do that. Any questions so far? The last thing I want to do is move on if the littlest thing is bothering you. I'm a little confused of how we got it.
Do another one.
I was going to do another one actually. Well, actually, yeah, we could just do that. Although the last thing I want is to get one that is messed up. Seven over 9 minus 1 over 2. So now we're doing subtraction, which, my friends, is the same thing as adding. Okay. It is the same thing as addition. You want to look for the least common denominator. So, yes, you guessed it. You build your racetrack. Put the 9, put the 2. You know what? Always put the lower number at the top. That's going to be like a new little trick that you might want to always do. Just so that you save time. 2. Let's lay out all of its multiples. 2 is a nice and fun one. 2, 4, 6, 8, 10, 12, 14, 16. Oh my gosh. I should go a little more, because I already know what's to come. What if you didn't spot that and you went a little further? You went up to 20. Well, when we start with the 9, guess what? 9 times 2, what is it? 18. You already found it right off the bat. But this is a good example to spot how some numbers you might have to lay out all of its multiples, or a big chunk of it, and then the other one, it's just multiplying it by 2. All in all, what you're always trying to do is find the matching number that they both have in common, the least common denominator. So, if 18 is what these get converted to, 18 minus 18, what do my numerators become? Well, ask yourself. This 9 over here, what did you multiply by to create that 18?
2.
So 7 times 2 is?
18.
7 times 2.
14.
14. This 2, what did you multiply by to create that 18?
9.
So ask yourself, what is 1 times 9?
9.
Now that they have the same denominator, just like addition, you could just subtract the numerators right off the bat. What is 14 minus 9?
Oh, yeah.
And no, I forgot to say this with the adding one. The 18 is not 18 minus 18 or 18 plus 18. It's just all gets brought over. It's the same denominator for what your answer is going to become. Question. 5 over 18. 5 over 18, could that be simplified? No. Is it proper or improper? Which means that's your answer, 5 over 18. Boom! Easy peasy. Lemon. Doug, finish that. Finish the rest of my sentence. There you go. So, 5 over 18 is the final answer. This racetrack, obviously I'm showing stuff for those of you that probably never seen stuff like this, and this is obviously the stuff that helps you learn. Through natural practice, you'll bypass the racetrack and you'll be able to know what number both of them have in common, right? But only through practice. This method is used, again, for those of you that probably haven't dealt with adding or subtracting fractions by hand. Okay, so that is in essence adding and subtracting, except I got to go over one last thing in terms of adding and subtracting, which is the big one, which there's a lot of in this worksheet. By the way, why are we doing this? And why are we going over this without a calculator? Why is this in the first week of our quarter? Why are we doing this all by hand? Why are we learning all these tricks? Again, for those GED folks in here, the first 5 questions you are not allowed to use a calculator, which means guess what they're going to throw at you? Stuff just like this, which means you need to know how to do it by hand. Sure, you could be like one of those students that say, oh, it's just 5 questions. If I get them all wrong, I don't care. What I care more about are those remaining 40 questions that I am allowed to use the calculator on. If you want to have that mentality, okay, you might pass. But you don't want that mentality, because those are 5 easy points that you can get if you just do a little practice with hand work. So, why am I going over this one? This one's... Okay, let's go over it. 4 and 1/16 minus 1 3/8. So this is obviously subtracting mixed fractions. There are 2 ways to add and subtract mixed fractions. I'm going to do something rare and show you the math book way, even the math YouTube way. The way, if you ever type on YouTube how to add or subtract mixed fractions, they'll probably go over this method. I don't know why that's the standard one, when for some reason every student ends up liking the second way to do it. But I'm going to show you anyways, just because, I mean, I got it. The first way, stack them up. Why? Because it's just more visually appealing. Why not? So this is what we got to do, my friends. The racetrack still comes into play here. What we got to do, don't erase what you just did. You could do on the side what I'm about to do, but don't start erasing. I just want to very quickly show you this. If this if we had this as a problem, these ones are actually pretty straightforward. If you notice, think of it as having 2 columns, one there and one there. One for the fraction side and one for the whole number side. Are the fraction side, do they have the same denominator?
Yeah.
Yeah, it's 8, right? Which means, because they have the same denominator, you could just subtract, easy peasy, 3 minus 2. 3 minus 2 is what? 1 over 8. It still stays the same denominator. Move on to this column. 4 minus 1 is what? Boom, you're done. 3 1/8. That easy, right? And same thing if it was addition. You're pretty much always just trying to find the same denominator. In this case, it was already given to us. So all we did was subtract the numerators, and then we subtracted the whole numbers. Easy, right? Obviously, the challenge is when we don't have the same denominator. And the challenge is what happens when the numerator of the first number is smaller than the bottom one. That's where the confusion comes into play, which is why students end up liking the second option. But let's continue on with this first option. Let's go on to our original problem. This one. So, same thing. Oh man. Same thing. Fraction column, whole number column. Tell me, on the fraction column, do they have the same denominator? No. So guess what? You still resort to, I forgot, we made a new rule. Lowest number at the top. We do the same thing. You try to find the least common denominator. What are the multiples of 8? 8 times 1 is 8. 8 times 2 is what? Oh my God, you could stop right then and there. Because believe it or not, you just found it. 16 is the matching one. Sure, you didn't have to change the 16, but you just don't have to change it is all. They have matching denominators. The 8, when multiplied by 2, creates 16, which matches the other one. So, the 16 is the matching denominator. So, if you want, you can rewrite it. Rewrite your whole fraction. This one stayed the same, 1 over 16 minus 1. What did you multiply this 8 by to create 16? 2, which means you have to do the same to the top. 3 times 2 is 6 over 16. That's your new problem. So really no difference so far. All we did was find the least common denominator the same way we did before. No difference here. And if that 1 was not a 1, if it was anything greater than 6, this would have been easy, right? We just do the number minus 6. We get our new numerator over 16, and then 4 minus 1, easy peasy. But we're going over this problem to show you what happens when your first number happens to be smaller than the bottom one, because you can't do 1 minus 6. I mean, you technically can. You could get a negative, but we're not there yet, folks. 1 minus 6. Okay, we're still good. 1 minus 6 can't be done. But just like in standard subtraction, what did we do? What do we do in a situation like this here? Let's pretend this is a 2 and this is an 22 minus 18. Do we remember how to subtract by hand? 2 minus 8 can't be done, so what did we do? We borrowed from the one before, the number right next to the 2. We took the 1, we took a whole number from the 2, leaving it as a 1, and we threw that whole number onto the 2, making it a 12. That's when we ask ourselves, what's 12 minus 8? 1 minus 1 is 0, so your answer is 4. This whole borrowing is what's going to help us here with the subtraction of mixed numbers. what we end up doing, this is where the confusion comes into play, so if I've already lost you, you might want to still try to follow along, but you probably might like the next one. What was that?
317.
Yeah, so this is what we do, my friends. If this is the one that you want to borrow from to make it bigger, we borrow it from the whole number, leaving it as a 3. Right? Nothing too hard so far. But no, you do not get that whole number that you borrowed and you don't put it next to the 1 to create an 11. You don't do that. What you end up doing is putting that whole number how would I phrase it so that it makes a lot more sense? We have a 16 here, am I right?
Yeah.
We have a 1 there, am I right? Ask yourself, what's 16 plus 1?
16.
16
Oh,
plus
17.
1. 17, right? Yeah, that's pretty much the trick. I don't know how else. Don't really worry about the why of things, but if you treat that as a trick to your disposal, when you take away one whole number from the 4, leaving it as a 3, what you end up doing is putting it on top of the 16 and the original 1, making it a 17. So overall, all you're really doing is, if the original, or it was 1, right? If the original was 1 and over 16, you pretty much add the numerator and denominator. Add them. 16 plus 1, 17, right? Which means this 1 turns into a 17. Did that make sense? It's a little choppy, my explanation. I apologize. But it becomes 3 and 17 over 16. Why do we do all of that? Why do we go through all that craziness? Pretty straightforward. Because what we can do now is what we did before, which was subtract our fraction column and subtract our whole number column. 17 minus 6 is what? 11 over 16. 3 minus 1 is what? 2. The final answer is 2 11/16. That's the borrowing method for subtracting mixed numbers. I think this method is good for adding mixed numbers just because you never have to worry about the borrowing. You'll just find the common denominator of your fractions and then you'll just add. But always keep track of simplifying your final answer. Do you guys want to see the second way? The way I usually teach how to subtract and add mixed fractions?
No.
No.
It confuses.
Well, for some students, it becomes a lot easier. Let me erase all of this. This was our original problem. 4 and 1/16 minus 1 and 3/8. If you like the method that I just showed, all right, stick with it. Put your brain on pause and don't listen to what else I have to say. But this is the second way. Those are mixed fractions, am I right? How about yesterday we learned how to convert mixed fractions to improper fractions, improper to mixed, right? How about we just do that right off the bat? Let's convert these into improper fractions. How do we convert a mixed number to improper? Well, you do the whole, I don't got too much space, but 16 times 4 plus the top number, the 1. So ask yourself, what's 16 times 4? plus 1. 65 over the same denominator, 16. All right. Minus, what's 1 3/8 converted to an improper fraction? Well, what's 8 times 1? 8 plus 3? 11 over 8. So, this is why students like doing it this way, is because if you take that initial step of converting your mixed fractions to improper fractions, if you look at this right here, it is no different than what we were doing before. All you have to do now is just find the common denominator, which we know is 16, and what did we multiply this 8 by? It was 2, right? To create this 16, the matching denominator. So you do the same thing to the top. 11 times 2 is 22. So now all you do is 65 minus 22. This is an exact replica of what we were doing before. The reason why math and math books and math instructors teach the first initial way is just because doing this way, doing this method, it just happens to give you large numbers such as 65 or 22, right? And you know, if you're given larger numbers, you might end up getting into the hundreds. But if doing multiplication by hand, division by hand is easy to you with large numbers, this is easy. You just find the common denominator and then you just straight up do the subtraction that's necessary. What is 65 minus 22? Oh man, it came out slanted. What is it? Do I have to show this? 5 minus 2 is 3. 6 minus 2 is 4. 43 over 16. So 43 over 16 is your final answer?
Yeah, break it down. Divide.
Yeah. You're always going to ask yourself, could the fraction be simplified? And once it's simplified, if it's still an improper form, convert it to mixed number. So at this stage, all you would really do is simplify or convert to mixed number first. Is up to you. But you'll just revert back to mixed number form. So there's your two ways of subtracting and adding mixed numbers. I'll let you guys convert that on your own. I'll let you simplify that and convert that on your own. Any questions? Yeah.
Unless it's stated in the question, should you always leave your answer like this, or you have to also change it?
You must always, actually, it shouldn't even state it. It shouldn't say leave your answer in mixed number form. You don't ever want to leave your final answer as improper. That's why they call it improper. It's because math hates it. It calls it improper. It finds it disgusting. It wants it in simplified mixed number form always. All right? Okay. I know that was a lot, but hopefully you got it. Because the next one that we're doing is multiplying and dividing. And like I said before, it's actually the simplest one of the two. It's the simpler one of the two. How do you multiply fractions? Does anyone know?
716.
Luis. Always shouting out the answer. So, no, unlike adding and subtracting, no, you do not have to find a least common denominator. That's why multiplying and dividing are easy. All you got to do is multiply straight across. 7 times 1 is what? 8 times 2 is? Could this be simplified? No, hint because of that 7. That's a unique number. Use those unique numbers to your advantage. You already know 16 can't be divided by 7, so no point to even check any more simplification. 7 over 16 is the final answer. Yes, is that easy? You multiply straight across. I think the hard part of multiplying fractions is when you multiply straight across the way we just did, and you end up getting large numbers, and then you'd have to simplify those large numbers. But that shouldn't be too challenging because all it is simplification at that point. We're just practicing our skill from yesterday, which is simplifying. What about division, though? What if we were given I don't like that. So division, how do we divide? No, you do not just divide straight across. What we do is
Cross, I mean a diagonal?
So no.
No?
What we end up doing is, yes, we convert, so math does not like division in terms of fraction, so it just happened to say, man, forget about dividing fractions. Convert this into a multiplication problem. It tells us, get the second fraction, by the way, always the second fraction, never the first. Always the first. Sorry. Always the second fraction. And what you end up doing is flip it. So if it was 1 over 2, what we end up doing is 2 over 1. Why do we do that? Is because we then convert not only the numbers, but we also convert the division sign into a multiplication sign. So pretty much there is no such thing as a division of fractions. All we do is flip the second fraction and make it into a multiplication problem. Because now all you got to do is multiply straight across. 3 times 2 is what? 8 times 1 is? 6 over 8. Could that be simplified?
Yes.
So, does division of fractions make sense? Yes, you always flip the second. Whenever you see a division sign, it's technically a multiplication sign. You multiply straight across after you flip the second fraction. Yeah.
So if you did that, you did that same thing in division, and you come out with the same answer if you didn't flip them. If you just found out how many times 3 went in.
We're pretty much good to go. We are done. Except for one last thing. In case you are given mixed fractions to multiply and or divide. And how do you do this? Well, I mean, we just went over how to add and subtract mixed numbers, and I think it was pretty clear that the second way was the easiest way. I recommend doing that for multiplying, dividing of mixed fractions. Convert these into improper fractions. 2 times 1 is 2, plus 1 is 3 over 2, times 5 times 1 is 5, plus 1 is 6 over 5, and guess what? You multiply straight across now. Isn't that second way just so much easier? It's like when you just see two standard fractions with no mixed numbers all around, it's just easier to find the common denominator. It's easier just to multiply straight across. It's just a lot simpler from what I see. Students like that way a lot more. They just, whenever they see a mixed number, they just immediately convert to improper. But just fair warning, if you do that, you might be having to deal with a lot of large multiplying of numbers. Okay. Now, my friends, we're done. Unless there's any questions.
What about dividing mixed?
Same thing.
Same thing?
Convert to improper? That's actually a good one. Let's pretend this happened to be division. You do the same conversion,
Okay.
but guess what? You make it into a multiplication problem by flipping the second. Flipping the second fraction. Okay. Now we're done.